Welcome to Malabar College of Engineering and Technology online classes. Today I am going to discuss again about Fourier integrals and transforms examples. Here we take an example. Using Fourier integral representation, show that integral 0 to infinity sine omega pi sine x omega d omega by 1 minus omega square equal to pi by 2 sine x in between 0 and pi equal to 0 x greater than pi. So here sin x is given here sin x. So we take f of x equal to sin x. Don't take pi by 2 as I told you before. Pi by 2 is a constant. We always take the function here sin x like this. In between 0 and pi here equal to 0 sin x greater than pi. Now in the question we have sin x omega here, sin function here. So we take Fourier sine integral of f of x is f of x equal to integral 0 to infinity b omega sin x omega d omega, where b omega equal to 2 by pi is integral 0 to infinity f of v sin omega v dv, and f of v is f of x, which is sin v here. Substituting f of v equal to sin v, we will get like this: 2 by pi integral 0 to pi sin v omega v dv, and we have 2 by pi integral 0 to pi sin v omega v dv here. Then here sin v sin omega v, we have to apply sin c sin d formula. What is sin c sin d? It is equal to 1 by 2 into cos c minus d minus cos c plus d. So we apply the formula. In place of c we have v, and in place of d we have omega v. So v minus omega v, which is v, if we are taking out 1 minus omega v, we will get. So c minus d is 1 minus v omega v, 1 minus omega into v, and c plus d is same. It is the difference is in place of minus it is plus here. So we'll get 1 plus omega v here. So we are applying the formula for sin v sin omega v, which is 2 by pi 1 by 2 into cos c minus d is 1 minus omega v minus cos c plus d is 1 plus omega v dv, and integrating this function here, 2 and 2 is cancelled here. Integrating this function cos, we see that integral of cos is sin 1 minus omega v, and we are integrating with respect to dv. So the together with 1 minus omega is there, so we have to divide here 1 minus omega minus cos 1 plus this integral of cos is again sin 1 plus omega into v divided by 1 plus omega. The parameter is 1 plus omega here to divide, so we have to divide 1 plus omega. The integral is from 0 to pi. Next, which is equal to, we have to apply the upper limit pi here. So in place of v we have to write pi here, minus, to apply lower limit 0, sin 0 is 0. So I am writing here the total is 0 here. So we have only this first term is sin 1 minus omega into pi by 1 minus omega will come. Here also similarly, the upper limit if we are applying in place of v, we have pi, we have pi here, and the lower limit if we are applying 0, sin 0 is 0 here. So we have only two terms here. Next we have to find out what is sin 1 plus omega pi and 1 minus omega pi. First of all I am taking sin 1 plus omega pi, which is pi. If you are multiplying pi, sin pi plus pi omega, we know sin a plus b is sin a cos b plus cos a sin b. Sin pi is 0, cos pi is negative 1. Sin pi is 0, cos pi is negative 1 here. So this term fully 0 and cos pi is negative 1. The remaining is sin pi omega. So it is sin pi omega, which is equal to minus sin pi omega. Similarly, we will get sin 1 minus pi omega. 1 minus pi omega is minus here. So minus of minus is positive here. So sin pi omega will get. So sin 1 plus omega, this one is minus sin pi omega. So this I am writing minus. So this minus and this sin is minus here. Here minus, it is minus here. So minus of minus, this will become positive. This is sin pi omega, and this first one 1 minus omega pi is sin pi omega here. So minus of minus is positive here. So taking sin pi omega out from these two terms, take the common factor out, and the remaining is 1 by 1 minus omega, 1 by 1 plus omega, plus will come. This we have to cross multiply again. 1 into 1 plus omega, 1 plus omega, plus 1 into 1 minus omega, 1 minus omega. Omega cancelled, 1 plus 1 it is 2. A plus b into a minus b, 1 plus omega into 1 minus omega, it is 1 minus omega square. It is 2 by 1 minus omega square. So this one is equal to 2 by pi into this 2 I am writing here first. So 2 by pi into this substitution is 1 by 1 minus omega square. So 1 sin pi omega by 1 minus omega square. Therefore f of x equal to, substituting this value in the question, integral 0 to infinity 2 by pi sin pi omega by 1 minus omega and omega square into sin x omega d omega, which is equal to 2 by pi into integral, this 2 by pi is a constant, take it out, integral 0 to infinity sin pi omega sin x omega by 1 minus omega square d omega, and taking 2 by pi to the left side, this will come pi by 2 into 2 by pi will become pi by 2 into f of x, and f of x we have taken sin x, so we have pi by 2 into sin x in between 0 and pi. And if you substitute pi here, we see that it is sin 0 here, so sin 0 is 0 and here is 0, there is no point of discontinuity, note. So next question we have to take using Fourier integral, show that integral 0 to infinity cos half pi omega by 1 minus omega square cos x omega d omega equal to half pi cos omega cos x 0 less than mod x less than half pi equal to 0 greater than half pi. So we take here cos x as f of x equal to cos x equal to 0 in between 0 and pi by 2. 1 by 2 pi means it is pi by 2 and equal to 0 greater than or equal to pi by 2. So and we have cos function here, so cos x omega here, so we take cosine integral of f of x equal to integral 0 to infinity a omega cos x omega d omega, where a omega equal to 2 by pi f of v integral f of v cos pi omega v dv, and f of v is f of x which is cos x which is cos v here, so we have to substitute f of v cos v here, and here we have cos c cos d formula, which is half into cos c plus d cos c minus d, and c is v, d is omega v, taking v out, we see it is 1 plus omega into v and 1 minus omega into v in place of c plus d and c minus d. We have to substitute cos c plus d here first. So cos c plus d means cos 1 plus omega into v, cos c minus, this is plus here, into cos c minus d means cos 1 minus omega into v dv, and we have to integrate again as before in question we have explained. It is integral 0 to pi by 2. Why integral 0 to pi by 2? It is 0 to pi by 2 here given, then 1 by 2 into this formula we already have applied, and we have to integrate cos, which is sin 1 plus omega v divided by 1 plus omega, and this one integral sin again 1 minus omega v by 1 minus omega, integral is from 0 to pi by 2, and 2 cancelled here, 1 by pi take out. We have to apply the upper limit here pi by 2. This I am applying the upper limit pi by 2. It is in place of v we have to write pi by 2. All the other things are same here. Minus lower limit is 0 here, sin 0 is 0, no need to write. Similarly here also upper limit is pi by 2 I have applied. Lower limit is 0, no need to write 0 here. Then we have to simplify sin 1 plus omega into pi by 2 is 1, which is multiplying by pi by 2 here, sin pi by 2 plus pi by 2 omega b, and we know it is sin a plus b sin a cos b plus cos a sin b, and we know cos pi by 2 is 0 and sin pi by 2 is 1 here, so this term is vanished here, so this 1 into cos pi by 2 omega v will get, so this is cos pi by 2 omega v. Similarly this is also cos pi by 2 omega v we will get. So this 1 by pi 1 plus omega pi by 2 by 1 plus omega etc. The step, this we got sin 1 plus pi omega pi by 2 equal to cos pi by 2 omega. This is also cos pi by 2 omega. So in place of this we have to write cos pi by 2 omega. In place of this we have to write cos pi by 2 omega. And this is divided by omega here, divided by 1 minus omega here, and 1 by pi is out here. So continuing, this one common factor we have to take out. Common factor is cos pi by 2 omega, taking it out, and 1 by 1 plus omega here, 1 by 1 minus omega. We have to cross multiply as before. This is 2 by 1 minus omega square, and this one 2 I am writing first. 2 by pi cos half pi omega by, this one is 1 by 1 minus omega square. Substituting, this left side is pi by 2. This 2 by pi equal to 2 by pi cos half pi omega by 1 minus omega square. And in the question we have c f of f in f of x cos x pi omega d omega is there, that we have to write as it is. Then taking 2 by pi to left side, so this full term will come equal to pi by 2 into f of x, which is equal to pi by 2 into f of x is cos x here, in between 0 and half pi. And if you substitute here half pi by 2, we know that in place of this pi, if you are substituting here this half pi, if you are substituting half pi, we have discontinuity or continuity points will come. We will see that it is cos half pi, which is cos 90. Cos 90 is 0. So here also 0. There is no point of discontinuity. This is what about the question. Next question I am taking using Fourier integral show that sin omega minus omega cos omega by omega square sin x omega d omega equal to half pi into x in between 0 and 1, 1 by 4 pi x equal to 1 equal to 0 if x greater than 1. Clearly we will see that there is a point of discontinuity if there are three functions. So we take f of x equal to the function is x here, don't take the constant. So is in between 0 and 1 equal to 0 x greater than 1. And it is sine here, so we take Fourier sine integral of f of x, which is integral b omega sin x omega d omega, where b omega equal to 2 by pi f of v integral f of v sin omega v dv. And in place of f of v f of x we have x here, so in place of f of v we have to substitute. Substituting f of v equal to v, the remaining is same here. So we have to integrate next 2 by pi into first function into integral of second type. So first function into v into integral of sine is minus cos omega v by omega. Together with v omega is coming, so we have to divide by omega, minus derivative of v with respect to v is 1. This minus I am writing here, integral of cos is sin omega v by this omega and omega multiply by omega square will come. And as I told you before that if you are integrating in this type, omega square will come, omega cube will come, second integral omega square will come, third integral omega cube will come, etc. in the denominator. Integral 0 to 1. This minus of minus I have made positive, 2 by pi into. Next we have to apply upper limit here. This minus is taken out. 1 into this minus of I have written here 1 into, in place of v I have to write 1, cos omega into 1, it is cos omega by omega, minus 0 if I am substituting 0 into any number is 0 here, so this is 0 here. Similarly if I am applying 1 here in this second one term, which is sin omega into 1 sin omega by omega square here, omega square, minus 0 if I am substituting sin 0 is 0. So this 0 I have to write here. Then this is 2 by pi into this positive term I am writing first. This one is sin omega by omega square. And here only omega is there. So we have to multiply numerator and denominator by omega. So omega cos omega will come here. By omega square will come here. Now writing this 2 by pi into this term together because denominator is same. So omega square will come denominator. So we will see that f of x equal to 2 by integral 0 to infinity. This we have to write completely here. And in the place of f of x there is sin omega x. So you have to write sin x omega d omega here. And taking this 2 by pi out and to the left side, we will see this from here to here. Without 2 by pi, we will see f of x into pi by 2 or pi by 2 into f of x, which is pi by 2 into f of x. And if you substitute 1 here, this is pi by 2 into 1 pi. And if you substitute 1 here, this is 0 here already. So this is pi by 2 and this is 0, which means there is at x equal to 1 there is a point of discontinuity. In this case we take the average pi by 2 into 1 plus 0 all divided by 2 or 1 by 2 into this, which means it is equal to pi by 4. So we will get three values. This equal to 1, first one pi by 2 x here. Second one it is pi by 4 we have simplified. Third one it is already 0 in the question we have written, it is 0 here. So this 0 we have to write. So this is what about the next question. So thanks for watching.